Hello everyone, welcome to a brand new live stream, and this is also my first live stream on this YouTube channel. So before proceeding any further, I would like to make my intention clear that what I want to discuss in this live stream so that you guys know exactly what I'll be covering in this video. So first of all, even I have no clue what I want to uh, cover in this video, because since this is my first live stream, I'm just figuring things out, like how I want to approach making YouTube videos. So having said that, I decided let's talk about some system design topics, because since the AI has gotten really good, and coding, I wouldn't say it's dead, but um, to a great extent can be generated using AI tools such as Claude and ChatGPT. So, I think focusing to instead of focusing too much on syntax, it's better to uh, build a strong understanding of how things work, and at the same time also work on your coding skills and learn a little bit of basic syntax, so that if AI generate codes, you're able to go through it, understand it, and then um, apply it to your coding skills. So I'll start with some system design questions regarding YouTube. So what I did, I asked a very simple prompt that I'm learning system design. Can you explain how YouTube is designed? Since YouTube is a very popular streaming platform, so understanding how it works is really important, because it lays the foundation of other social media application. And also YouTube stands out from other media because over here you can upload video footage uh, of 1 hour long. You have live streams running all the time. So how does YouTube manage all of those things and very seamlessly? So without any further ado, let's start. So this is the prompt generated by Claude. So let's go through it line by line and understand what it means. So YouTube is a great system design case study because it forces you to think about three hard problems at once: massive video storage, global low latency delivery, and write heavy metadata layer review and view comment likes. So what this actually means, YouTube is working on three different problems simultaneously. First is massive video storage. So as I said, 4K footage, they even if it's 5 minutes long, the size of that footage can go more than 1 GB. Now imagine millions of views are uploading 4K footage, because it has become a default and common resolution these days if you want the quality of your videos to be really good. So how does YouTube manage massive video storage? Now the second is, since these files are so large, um, delivering this to the end user can become a really big problem. So how does YouTube manages a very low latency? Now the second is write heavy metadata. Now every YouTube video has some metadata associated with it, such as uh, we have the views, we have likes, we have comments, we have shares, and if you are the producer of the video, then you can also view the analytics. So how does YouTube handle this write heavy metadata? So let me write this, note this down in an MD file, and I'll push this file to my GitHub repo. You can later access it. So YouTube, so here what, so let me recap this first paragraph. So YouTube solves three major problems. The first one is massive video storage. Second is um, global low latency, which means how are they able to deliver um, videos quickly to the end user. And the third one is write heavy metadata, because every video has views, likes, share, subscribers, and analytics. So how does YouTube manage all these information? Now I'll tell you a story about massive video storage. Why this is a really big problem? Because I started using a GoPro in which I can record a 4K footage at 120 FPS. That's the maximum frame rate that the GoPro can record. So one time I did record in that configuration, and when I tried to import it into my editing software, it failed. Obviously, because my laptop hardware is not compatible to support a 4K footage, but the time taken to import or copy the entire file in my computer almost took more than, like, I exactly don't remember, but 30 minutes, which is a lot for a 5 minute long video. Now we have professional YouTubers who are making hour-long videos in 4K. So you can imagine how much data YouTube is dealing with. So this is so Claude says that YouTube breaks its entire system into three layers. The first one is the upload path. Okay, so what happens in the upload path? So we have the user uploading the raw video. It hits a API slash load balancer and goes into a blob storage like S3 or GCS, not a database. And similarly, this is not limited just to video files, but also PDFs or any other kind of documents. They are typically stored as blob. Um, if you work on very small projects such as building a Pinterest clone, uh, in many YouTube videos you will find that they are using Cloudinary. So what happens? You upload an image to Cloudinary, it generates a unique URL for the image, and that image URL is stored in the database. So typically, I mean, that's how I have used personally, but I don't know whether YouTube also use the same approach. Now the second is we have a message queue Kafka, which triggers an async transcoding pipeline. So what does this transcoding pipeline do? So it's mentioned in the next line that its responsibility is to convert the single video file into different resolution, 144p to 4K, and also different formats. Now why is that required? Because we have a wide range of end users, and by that I mean they are on different devices, they are on different regions, they are on different network connectivity. So let's say the user uploaded a 4K footage and someone is viewing it on a device that doesn't support 4K. So are you going to just tell them, okay, you can't watch it since your hardware cannot support 4K footage? That's not what YouTube does. It creates a different lower resolution which is served to the end user. Now the next point is it's CPU heavy, so it's decoupled from the upload request itself. Now since we are creating multiple format for the same video, so obviously we will be relying on a lot of processing power, on a lot of memory. Now I don't know the exact process how it works, but uh, we'll see that. Now it's decoupled from the upload request itself. So what I think this means, even I'm not sure, that once a raw file is uploaded, in the background it creates different resolutions. So I think this is what it means, decoupled from the upload request itself. And then you obviously have the metadata such as caption, thumbnail, title, etc. So if I need to recap this, so I'll say that okay, we have the raw video and it goes into a S3 or GCS bucket. From there it's stored as a block, okay, and not in a database, not in DB. And then we have a message queue. Now I have a just another question. Does this message queue provide any other functionality other than transcoding pipeline? So I'll note this question down because I don't know that. Uh, so I'll say, does the message queue offer other functionality instead other than transcoding? Other than transcoding. And the next doubt that I have is why different format? I can understand why I need different resolution, but I don't know why it creates different format. Maybe some are better than other. For example, CSV is really diverse. You can easily insert data into various tools and softwares. Decoupled from the why transcoding is decoupled from the upload request. So even though I have some idea why they might be doing it, but I want to ask Claude and confirm why this process is decoupled. And then we have a message queue which performs the transcoding pipeline, and from here it creates different resolution. Say for example 144p to 4K and different formats. We have AVN1, VP9, so these are the formats. I've heard AV1 before, but this is the first time I'm listening to VPN or H.294. Fine, so this is layer 1. So what happens in layer 2? So here this is, I think, specifically talking about storage. So video files which are very large and immutable blobs. So I have a doubt. Are they really immutable blobs? Because in YouTube they have started to provide an inbuilt editor. Suppose there's a certain part which you want to trim after uploading because it's the reason why a video got copyright strike, or it's causing some dispute, or you just want to trim that part off. Um, so I'm not sure about this statement. So again, I'll just add this as a question. Um, video files are immutable. So I'll say, but YouTube offers inbuilt editor which allows to trim and edit videos. So does that mean their videos are still immutable? Okay, so now it says the metadata: view count, likes count, video information. How is this information built? So a mix of SQL and NoSQL key value stored for high write counters like view counts, which get patched or approximated rather than updated synchronously on every view. So if you have a YouTube channel, or if you have ever uh, focused on the views of a YouTube video, you will say that they stay stale for quite some time. And the reason is YouTube doesn't update the view count as soon as some new visitor lands on the video, because then you're making multiple API calls and trips to the server, which bogs the system down. So instead, what they do, they keep track of all the counts, and in batches they update these information. So let me note down this point. So metadata for videos like count on videos such as views, likes, comments, so are built using a mixture of SQL and NoSQL. Okay, fine. I want to still figure out what exactly do they use SQL for, and for NoSQL. By that I am trying to communicate is that how do you decide that you want to use SQL for so and so feature, and then you want to rely on NoSQL for building a different feature? So I think it's I don't know, probably read write concern, or uh, I assume since in NoSQL you cannot use joins, so in that case you rely on SQL. If you have um, so let me keep a note of this question. I don't want to make any assumption. So what YouTube feature is built using SQL, and which ones are built using NoSQL? Now the third, and I won't say the final layer, because YouTube is a really big software, and this is what Claude suggests. But if you really go deep into the system design for YouTube, you are going to find many more layers. But generally, on a quick overview of YouTube, I think these three layers are sufficient. So here we have the CDNs, Content Delivery Network. So videos aren't served from origin storage directly; they are pushed to a CDN. YouTube uses its own global edge network, Google Global Cache. So playbacks come from server physically near, and playback uses what is adaptive bit streaming. I assume based on your network quality, it automatically detects and find the most uh, smooth bitrate based on these two algorithms. This is what I think. So videos are not served. Videos answer from the origin storage directly. Okay. Instead uses CDN, and probably YouTube has its own CDN network called Google Global Cache. Google Global Cache. What is, I want to note down this point, what is adaptive bitrate streaming? And we have dash slash HLS. So now there are other core pieces in the YouTube ecosystem, which is the search and the recommendation. How do you search for a video for a topic which has millions of videos? And the second one is recommendation. Even though YouTube tracks your watch and search history, but still it's a massive problem to figure out what exactly uh, matches your taste. Uh, and then we have the read heavy versus write heavy split. So I'll just note this down. In YouTube, which features are read heavy and which are write heavy, and why? I want to know the reason why. So I'll say, so other components for YouTube are search slash recommendation, and then we have, I think that's it, search and recommendation. Probably there are more components, but as I dig deeper into this topic, I'll learn more about them, but for the time being this is good enough. So here they have Claude has given a very good point. It uses eventual consistency instead of strict consistency. For example, if I have a video and 20 people have landed on the video, so instead of showing the count as 20, it's showing 5. So the data is stale. Now, why is it stale? Because, as I said, YouTube updates such information in batches, not synchronously. So for a time period, it's okay to show stale data because it's not going to impact the efficiency or the correctness, I should say, of the software. But strict consistency is required in banking or software financial application, where you want the data to be reflected immediately. So you can just probably also note in YouTube which features use eventual consistency and which ones use strict consistency, and why. I think I don't think there's any YouTube feature which needs strict consistency. Okay, so it has summarized the YouTube architect in this flow diagram. We have the upload pipeline, then it goes to the storage S3, and then we have the transcoding pipeline to convert it into different resolutions and formats. And then to deliver those videos, Google has its own network of CDNs, and then we have the client playback. And apart from this main system, there's metadata, search, and recommendation. So want me to go deeper on any one piece, like how adaptive bitrate streaming actually work, or how they shard the view count database? which I will discuss in my next live stream. So, anyways, thank you guys so much for watching, and um, I'm planning to live stream every single day, and especially there's not going to be any specific topic that I will cover. It'll be totally based on what I feel like studying or reading. Uh, so, so if you found this video helpful, please do like, share, subscribe, and I'll meet you guys in my next videos. Thank you. Have a nice day, and GGWP.